In the previous video, we created the new strategy create use case, returning our use case. We received the repository here, and we created the handle method where we receive a context and a request, processing the strategy and returning the response. And we also created this helper right here that allows us to use an incoming request and create a strategy. So in this video, we are going to create the test cases for these two functions. Remember, we are going to create a new test file. In our case, since we will be testing this strategy create use case, we are going to use the exact same name, strategy create use case _ test. And again, we have a test case right here. We have two functions that we need to test. First, the handle, and then from create strategy request to strategy. This is pretty straightforward to test. So this is the exact same thing that we tested before. As you can see, before writing your test case, you can see that you need 1, 2, and 3 different test cases. So we are going to create a function called test. Then we are going to use the name of our function. You can keep it like this. I like to put an uppercase here in the name of the function, so I know that this is test, and then having an uppercase letter right here with the name of the function. Then we are going to be using t being a pointer of testing that t. Again, we want to execute this test in parallel, and we are going to need 3 different test cases. So we are going to create 3 different sub-tests for this testing we have in here, t.run, and we are going to test nil request returns error, invalid name returns error. So nil request returns error, and create a function with tt. Again, in this case, we want to execute tt.parallel, and here we need to implement the test case. We are going to create 2 more. This will be invalid name returns error, invalid name strategy name, and here strategy successfully obtained. So this is pretty straightforward. I will leave these test cases for you to implement. I won't implement these test cases right here. You can rely on what we did over here to do the exact same thing and implement this method on your own. The idea is that whenever you finish executing these test cases with coverage, you should have 100% coverage in this function right here. So I will leave the implementation of these test cases to you. I highly suggest you to clone the repo, or even better, fork the repo on your own so you can push your changes to your repo. Make these changes in here and make sure that whenever you execute this test case, you can have 100% coverage right here. What we do need to test is this handle method we have in here. So we are going to create another test case. In our case, it will be function test, and the name of the test will be this one. So in this case, create strategy use case _ handle. As you can see in here, I'm using the name of the interface that I'm testing. In this case, the create strategy use case, and then handle being the name of the method that I'm testing. If I have more than one method, I can create different test cases like this and call the different methods on my interface, and I can have multiple test cases, one for each method that I'm testing over this interface. In our case, we will be testing the handle method. Now let's take a look at the handle method. We know that we have 1, 2, 3 different return statements. So again, same as before, we will need 3 different subtests. So t.parallel in this case, and we will need 3 different subtests. Need 1, 2, and 3. The first test that we need to have is invalid request returns error. That is this return statement right here. We need an error from this function. So this will be invalid request returns error. Then we need to save the strategy using our repository, and we need to test this return statement right here. Error creating strategy returns error. And finally, strategy successfully created. So we have 3 different test cases for the 3 different return statements we have in our function. Again, keep in mind that whenever you are developing a function and you see 1, 2, 3, 7, 10 different return statements on the same function, you know that that function is probably doing a lot more than what it should be doing. So it is a really good candidate for splitting that function into 2 or 3 different functions, making sure that you have a single responsibility for each of the functions that you have. Now, focusing on the test cases, you can see that the first thing that we need to do in here is create our use case, because the handle method is part of the use case and not part of the package. And you can see that the use case is this strategy create use case we have in here. Notice that this is an unexported structure. It is a structure that is available only for the strategies package. And our test case, again, is in the same package, in the strategies package. So this is white box testing, meaning that we have access to all the internal artifacts within this package. So in this case, we will create our use case, will be a pointer to the create strategy use case. And now we can call use case that handle. You can see that the handle takes a context and a request. So we're going to create our context, will be context that background. We will create our request that will be a pointer to create strategy request. And in the handle, we will pass context and request. Notice that handle returns a create strategy response and an error. So we are going to have our response and the error. Now, what are we testing in this case? We are testing that invalid request returns an error. So in our case, if we pass an invalid request here, we want an error. So we want to make sure that if we have an error, we don't have any response. So the first thing will be assert that nil and make sure that we don't have any response. We are expecting an error, so assert not nil error, then assert that equal values, and we expect this in error.error. You can see that we are passing a valid request, but we are not defining in the request, we are not defining the name. And remember that the name is a required parameter that we have in our request. So here we should expect, let's say, invalid name. If we execute this with coverage, you can see right here that this is what we are testing with this first test case. That's why we have 3 different test cases. With the first test, we are testing this part right here. So we went through this statement right here. We attempted to create a strategy using the request. We went here, request was not nil, because we are passing an actual request from our test case. You can see right here, but the name is empty. So we are returning invalid name. And that's exactly what we have in here. So this test case is successfully implemented. Now let's go on this one. Error creating strategy returns error. We are going to pretty much copy and paste the same code we had before, but now we are going to define the name of the strategy. In our case, this will be the name, strategy name. So this is a valid name. Now what happens whenever we execute this test case? If we execute this right here, you can see that it is failing because we have an invalid memory access or nil pointing the reference. And the error is in our use case, line 43. And you can see that here we were able to get a valid strategy, but when we try to save this strategy, we are using the strategies repo in our use case. And notice that here, whenever we create the use case that we are going to call, this use case requires a strategy repository, and we are not passing that repository right here. So what we need to do in our case is create a mock for the strategies repository. We need to mock this port right here. You can see that we have 2 functions in here, and we need to mock this interface. In this lesson, I'm going to show you how we used to mock things before we have tools for doing that. And in the next video, we are going to introduce a library for doing exactly this. And this is an industry standard. You will find the same way of mocking pretty much everywhere you work with Go. But in this video, I wanted to show you what this library is doing under the hood. So we will create in the internal package right here, we will create another file in the mocks package, and we will call this strategy repository mock. Okay, and you can see the package is called mocks, and we want to mock this strategy repository. So I'm going to pretty much copy and paste this in here just to have the reference. But what we are going to do is create the mock for this interface. Okay, so we will create a new structure called strategies repository mock, and I'm going to export this so it is public. And this is a structure. Okay, now notice that inside this mock we need to implement this interface right here. This interface is what we have in our repository. I just copied that to have the code available, but you can see that our repository requires these 2 methods implemented by whoever is implementing this interface, right? What we are going to do is implement these 2 methods in the mock. For doing that, remember, we are going to define function, then mock, that will be a pointer to strategies repository mock, and we are going to implement this method right here. Then we are going to do the same with the getById. And we're going to remove this. We don't need it anymore. Now you can see that our strategies repository mock is implementing our strategies repository, that is what we have in the ports. Now we have two methods in here, insert and get by ID. What we want to do is change whatever this insert is returning. For doing that, for mocking and changing the behavior of this insert and letting whoever creates this mock define what this mock should return, is create two exported or public functions in here called insert function. Will be a function taking a context, a strategy, and returning a string and an error. You can see that this function right here has the exact same signature, this signature that you can see right here, than the signature that we have in the insert. It receives a context and a strategy, a pointer to a strategy, and returns a string and an error. So in our implementation, what we can do is just return m being the mock, and we can call this insert function and just pass the context and the strategy that we get. So we just call the insert function that we just created. If we do the same with our getById, we can create a getById function, and it is going to have this same signature that we have in here. It receives a context and an ID being a string and returns a pointer to a strategy and an error. And here in the getById, we can just return mock that getById function, passing the context and the ID. Okay, so you can see that our implementation of the mock has the insert function and the getById function, and whenever we call the actual implementation, we are calling the function that we have in here. And you can see that in here in the structure, we could have a name being of type string, we could have an ID being of type string. This is the structure's field name, and this is the type, field name, field type. In this case, the field name is insert function, and the type of this field is a function. In Go, the functions are primitive types, so you can use function as a type. That's exactly what we are doing here. Now, in our test case, one thing that we can do is have our strategies repo will be mocks that strategy repository mock. Okay, so you can see that we are saying that the repository will be mocks that strategy repository mock. So we are creating a new instance of our strategy repository mock. I'm going to remove these two fields from here, and our use case will be using this as the strategies repository. You can see in here it is failing, and the reason why it is failing is because we are creating our repository. If we go to the mock, we have our structure, but the methods that we implement in our structure are implemented to the pointer of the structure and not to a structure itself. We are not doing this. We are not implementing the method on the structure itself, but implementing the methods on the pointer. That's why here in our use case, we want to use a pointer to a mock. And here you can see that in our strategies repository, we do have access to the getById function and to the insert function. Whenever we call handle, you can see that the handle method is calling the insert method in the strategies repository. So from our test case, we do have access to our strategies repository that insert function, and we can define this function. So in this case, we can define it as a function receiving a context and a strategy, and here we can return whatever we want. So in our case, we will mock the behavior of our repository, and we will say that whenever you call the insert function in this mock, you should return a string and an error. What do we want to return in here? We are going to return an empty string, and then let's say errors.new, and we want to return some database error when inserting strategy. And as you can see, now when we execute this function, we have this error because we are expecting invalid name. That's what we are expecting in here, and the error that we actually got was some database error when inserting the strategy. So you can see that this is what we are getting from our use case handle. If we execute this again, you can see everything passing. And if we execute this with coverage, you can see right here in our strategies create use case, we were able to create the strategy from the request and then attempting to create the strategy calling the insert, and this insert returned an error. But we are able to do this because we are mocking the strategies repository. If you take a look in our test case, we are creating our use case. This use case right here is this use case. So we are creating the use case like this. And then the strategies repository is using the mock that we just created. Take a look at this mocks. That strategy repository mock has these exported and public fields, so we can modify these fields from the place where we create the mock. So in this case, we are defining this function and saying whenever you call the insert function, then execute this function that I can define in the test case. And you can see that I can do this because our mock is implementing the exact same port interface that I have in my ports. So this is the test case for making sure that when we have an error creating a strategy, we return the error. Now we can test this part right here. Let's mock what happens when we don't have an error and we are able to return the strategy from the database. In our test case, we are going to implement the strategy successfully created. So we're going to pretty much copy and paste all of this in the exact same way. But now, when we try to call this insert function, we are not going to return any error, and we are going to return strategy ID. And notice that at this point, we don't need to worry if this is a valid Mongo ID or not, because we don't know and we don't care if we are inserting this strategy in Mongo or Postgres or anywhere. We just need a valid strategy ID, and that can be any ID we want. Now you can see that if I execute this test case right here, I will have a failure when we are testing that we have a strategy successfully created. We want to check that we had a nil error, that we have a not nil response, and here we also want to check the response fields that we got from this response. So assert equal values, and we want to ensure that our response and you can see that the only field that we have in the response is strategy ID. And since we are mocking our repository to return this ID, that's exactly what we are going to expect in here. We execute the same test case again, and there you have it. We have our mock for our repository. If we execute this with coverage, you can see right here in our use cases, we are having 100% coverage in our use case because we are mocking the strategy repository here by using this mock. Now, as you can imagine, implementing this for all your interfaces and mocking your interfaces is not something that you are going to do manually like what we did in here, but I wanted to show you how you can implement mocks without any mocking framework whatsoever. I hope you took something from this lesson. Thank you for the attention and see you in the next one.